Okay, hello. um, this video is going to involve the TRS-80 color computers again. It's a follow-up math video, and I'm going to be making one more after this. And then that's it for math videos on this channel. But I just wanted to explain this math principle first before we get into writing the program. The actual program. So it goes like this. I squared is equal to -1. Okay, so when you take the square root of -1, you're going to get an answer of I. And what I means is it's an imaginary number because there are no two numbers on the positive or negative side of the number line that when multiplied will equal that when squared will equal -1. So the idea is that if you square 1, you'll end up with 1. If you square -1, you're going to end up with 1. So no matter which side of the number line you're on, you're going to get the same answer. And in math, sometimes we need to use imaginary numbers so that we can get this result here. So if we can't square -1 and we can't square 1, well, we can, but we're going to get 1, and that's not what we want. So our third option here is the I. If we square I, we're going to get that -1 that we can't get normally. So again, if you take the square root of -1, you'll have I by itself as an imaginary number. Okay, so down to the bottom here, if we apply this to an actual negative number other than -1, which we can do, we're going to write it out as the square root of -4 equals, and then what happens is we have to break it apart because there is no square root of -4. There are no two numbers that when multiplied will give you -4. However, we can break it down into two parts. Now, if you remember from math, anything times 1 is the original number, so you can put 1 times any number and you're going to get the number, and this is how we're able to end up with our answer. So we're going to break it down into the square. We're going to break -4, the square root of -4, down into the square root of -1 multiplied by the square root of 4. And we're going to get two answers. We're going to get I for -1, and we're going to get 4, we're going to get 2 for the square root of 4. So again, the square root of -1 is I, and the square root of 4 is 2. And this is the form that you put it in as your answer. The number comes first, the imaginary part comes second. So the answer to the square root of -4 is 2i. Now we're going to get into the actual program part of this video, which is going to enable the TRS-80 to recognize negative square roots. Okay, so now we are away from the chalkboard and we are into our color basic by Microsoft, copyright 1982. Yeah, and this is via a TRS-80 Color Computer 1 emulator. You can use the real thing, or you can use a Color Computer 2, or even a TRS-80, I suspect, an original. But anyway, So we're going to start the program here. And before we do that, we are going to cover the concept of printing a square root on this particular computer. Now, if we wanted to print a square root, we just put print square, SQR, for short, in parentheses, and then we put whatever number we want to find the square root of in the parentheses and press enter, and it will give me the square root of that number, which is correct. 4 squared is 16. We'll try another one. Print square root of 25, and the answer is 5. Okay, so we know that works. However, but before we get to that, I'll just cover how you would reverse this answer back to the original problem. So we would want to print 5 to the second, which is 5 squared, and it will give us the answer 25. The same thing with 4, print 4 to the second, and we will get 16. So this works in tandem here. But the problem is, if we want to find a square root of a negative number, say negative 25, what happens is it gives us an FC error, and it will not evaluate that statement because it does not recognize the a negative number as being square, because there's no such thing. But sometimes we need to find negative square roots, okay? And I'm going to show you how to do that. So let's see. Now I showed you how to raise it to a power, and I showed you how to find the square root. But the problem is we can't find negative square roots. But the computer does recognize the difference between negatives and positives, because if you do this, and you multiply negative 25 times 2, the answer should be negative 50, and it is. So it recognizes multiplication, negatives and positives, but not here. It's not in its bias. So we have to write an application if we want to find different square roots. So that's what we're going to do. The first line is a print statement. What square root? Okay. So we're going to run this program. Actually, we're going to put a line in here and clear the screen first. So when we run our program, we don't have all this garbage on the screen. So it says what square root. Now we have to do line 2. We're going to put input A, and that's going to be our variable. Now when we run the program again, it's going to pause and ask us, well, what number do you want? We're going to say 25. That's where the program ends, because it doesn't go any farther. But we're going to make it go farther. Okay, we're going to start off with if A, the variable, is greater than or equal to 1. So if our number is greater than or equal to 1, we are going to print the square root of that particular variable. Okay. Now we're going to run this program, and when we put in 25, it gave me an error. What did I do wrong? Okay. I forgot to put a then statement in there. Edit 3. If A is greater than or equal to 1, then print the square root of that variable. So run. Now we want to find the square root of 25. 5. Fine, it does it. We want to find the square root of 64, which should be 8. It does it. So it's operational. We want to find the square root of 4, 2. But what happens if we want to find the square root of negative 25? What's going to happen? Nothing. Okay? Now, note that we're not getting an error. Okay, remember before we were getting that error? So we're making progress here. So we need to tell it what to do if A is less than 1, which would be any negative number, -1, -2, all the way down the line. So if A is a negative number, then what we want it to do is print the square root, not of A, okay? Because if we did that, and our input was -25, we would get an error. Because it would attempt to print the square root of a negative number, and we would get that error, and that's what we don't want. So what we have to do is have it print the opposite of A. So when we input -25, for example, it's going to come here, and we're going to get the opposite of -A, which, if you know math, if you have, well, it's going to be the opposite of A. So the opposite of -25 in this case would be a +25. However, we need to expand this line a little bit because that's not the answer we want. We want to make sure that we include an imaginary number here. So we're going to, after it prints the square root, we're going to have our imaginary part here. So we're telling it what to do when it encounters a negative square root. So line 5 is going to be our famous Inky statement. So we're going to put string A equals Inky's string. And we're going to put if a $ equals spacebar, then 0, which means it will go to 0. However, if a $ equals Q for quit, then end, the program will end. And we're going to put go to 5, so it's going to come through the program, give us our answer, and then it's going to cycle. It's going to cycle and cycle and cycle until we either press the space bar for another try or hit the Q button to end the program. If we hit anything else, any number key, any letter key, it will do nothing. So you may either press the space bar or Q, or you can break the program. So what square root do we want? 25. It's, oh boy, TM error. What did I do now? Oh, insert an equal sign there. Now these error codes are incredibly helpful, because if we didn't have them, then when we made a mistake like that and the program wasn't working, we would have no idea why. So the different error codes allow you to look up the error code and deduce from the error code, what the problem could be. It's usually 1 or 2 or 3 things. And I don't know how many error codes there are, but there's quite a few, maybe like 50 in BASIC. So you don't have to memorize them. I don't know them all. You just look them up if you don't know what they are. So we're going to run the program again. What square root? Square root of 25, and our answer is 5. I'm going to hit the space bar. It's going to give us another try. Square root of 64 is 8. hit the space bar, square root of 4 is 2, hit the space bar, square root of 3 is a decimal, so we're doing fine. But let's try square root of negative 25. Okay, and now we get our answer, 5i. Okay, and we're going to try again. How about negative 64? What's the square root of that? 8i. We're going to do negative 4, 2i. We'll do another one, negative 3, 1.73205081i, imaginary. So these are all imaginary numbers. Square root of negative 81, 9i. So now our computer recognizes both positive and negative square roots, and it's able to evaluate them with this simple little program. I'll call it a small application. And there, back in the day here when this was made, there weren't any windows, but if there were, this might be an application that you could choose from, on your Windows taskbar or somewhere else. And you could have different applications, but at this time you could only run one at a time, or you could create your own software, and this is a small piece of how to do that. If you wanted to make your own calculator, this would be part of that. As I said, the computer itself can do any calculation you give it. 7 times 7 equals 49. It can do division, print 7 divided by 7. But as we get more complicated, we have to use different techniques because it's only a computer. Okay, it's not a calculator. But the only other way to find your negative square roots would either be by hand, or with a scientific calculator, or with a graphing calculator, or some other application. And if you're not good at doing them by hand for some reason, this would be another choice. So I hope you enjoyed this video and have a good day.